Okay, so welcome to Math 119-312, the mathematics of pandemics and a risk-benefit analysis of responses. So today is lecture 10, and we're going to talk about the color metrics that Massachusetts is using to determine how we should view the presence of COVID in various parts of the state. These were metrics that were done while the pandemic has been raging. And so it is not surprising that the metrics may not capture everything that was hoped when they were created. And as we get more data, as we see more things, as we see which things really matter, we can get a better sense of what are either the right metrics or probably a more natural question, what are better metrics? How prevalent is it in what I want to do now is metrics. It seems like somebody has their microphone on. They want to mute that. Or can I just mute everything?
The president's remarks at the debate last Tuesday night, encouraging all of us to
somebody has the microphone on. Please hit mute.
I think someone named Martin has their mic on.
I think there's a general concern about Trump supporters potentially showing up.
I have just muted everybody, so it's much easier. It's almost like shoot everybody and let God sort it out later. So, from a great Simpsons episode, many other places. So, for those of you who want to speak, please just unmute yourself later. Okay. Could somebody who is responsible unmute themselves from Zoom land and just say something so that I know that you can unmute yourself?
Test.
Yes. Perfect. Excellent. Wonderful. Okay, so we will continue now. I should have actually paused the recording. All right. All right, so here is a snapshot from the Williams College dashboard. Extremely transparent, lets everybody know what is going on. So in the past 24 hours, there have been no positive test results. There is one in the past 7 days. There are now 4 students and 1 faculty staff that are listed. I actually thought this was a little bit surprising. I thought there had only been 3 students listed as of recently.
I found out about it yesterday.
Okay, so there was a student who's tested positive recently.
I was assuming that Friday.
Right, and maybe what happened is it's positive test results in the last 24 hours. So maybe the test result is from more than 24 hours ago, and that's why it was missed. So you always have to be careful about how you look at data like this, as to how accurate is the snapshot. When was the test done? Do you count them as a positive when the test is done at that moment, or when the test result comes in? And that can make a huge difference as to when do you start the clock. I would say you should start the clock from the moment the test happens. All right, so there's been over 3,000 tests in the last week, over 17,000 tests in basically a month and a half. Here is a snapshot of Berkshire County. We are in the yellow for the entire county, averaging 1.6 cases per 100,000. And this is a nice, good snapshot of what's going on. Here is a more detailed map county, not county by county, but town by town. And so the key thing to see here, let's get rid of this. The key thing here is the legend. So a town is gray if it has less than 5 reported cases. It would make a tremendous difference in Williamstown if that was a less than or equal to versus a less than. If it was a less than or equal to, I would know for sure that kids would be able to go back to school on Thursday this week. With a strictly less than, I don't know that. You are green if you have fewer than 4 cases on average per 100,000. You are yellow if you have 4 to 8 cases per 100,000. And you are red if you are averaging more than 8 cases per 100,000. Anybody know roughly the population of Williamstown, just for perspective? A little bit under 8,000, and that includes the students. Okay. Zooming in a little bit on our part of the state, our corner, Williamstown has a total case count of 96, 5 in the past 2 weeks. So that is just enough to push us into yellow. The average daily incidence per 100,000 becomes 4.85. And so we're a little bit lower because I believe the previous 2-week cycle we were 6 and we went down to 5. So we're at least moving in the right direction. We've done 14,000 tests, which is a lot. You could actually click on other parts of the state and get a sense of just how often are various parts being tested. And then I want to just put things a little bit in perspective. So does anybody know what is the smallest state in the union in terms of area? Yeah, probably Rhode Island, which is being displayed right now. Rhode Island is the smallest state, Little Rhodey, one of its many nicknames. Its area is about 1,200 square miles. Berkshire County, its area is about 946 square miles. So we're about 78%, about 3/4 the size of Rhode Island, with about 1/8 of the population. So one of the things I've been trying to hammer home to you all semester is to look at things in the right way to make meaningful comparisons. So comparably, we're a little bit smaller than Rhode Island, but with a significantly less population density. And I think it's sometimes nice to be able to look at things like this to just get a sense of just what are we talking about. All right, so now I'm going to shift the slides by our group. And so COVID metrics for Berkshire County exemplified by Williamstown. And so here I threw in on the right a map of Berkshire County, and you can see all the different towns. Any town strike you as particularly interesting or strange, or they all look pretty reasonable? So Hancock is extremely stretched out, running parallel to New Ashford, Lanesboro, and Pittsfield, bordering Richmond and Williamstown. And so they are so small in terms of their population that they do not have a full school system. They actually have an agreement with the Mount Greylock Regional School District to send their kids to the middle high school. But this is actually a real problem in terms of transportation issue. When you have a town like that, and you have to do decisions on a town basis, how do you choose bus routes? How do you deal with stuff like that? All right. So if anybody from the group wants to speak up, if I'm missing anything, please just holler, raise your hand. I will try to do the slides as best as I can. Most of it is pretty self-explanatory. The only real changes I've done to your slides is I've tried to expand the image a little bit. Given that so many people are going to be watching this on small devices, use as much space as you can on a slide. This is just a good general rule for presentation. Blank space should be avoided at all costs. At the same time, do not throw so much information on your slide that people are spending their time reading the slide and not paying attention to you. The last thing is there's often a tendency in the non-mathematical world to have pretty slides with lots of different nice images and whatnot. I try to put a few of them in, but as a mathematician, I care more for content. But by all means, try to make things easy and pleasant on the eye. Color coding is wonderful. When you look at the slide, you can clearly see, oh, green range, yellow range, red range. Excellent. And so this is showing what would happen according to the state formula using a population of 7,754 for Williamstown and 694,583 for Boston. Are people surprised that the population of Boston is less than 700,000? Why is this not surprising?
Because Boston has a bunch of suburbs.
Yeah, Boston has a bunch of suburbs and a bunch of places near it. So what's actually called Boston may not have a tremendous number of people, but the Boston metropolitan region, and depending on how you define things, with some definitions, you might almost say Boston all the way down to Atlanta is a giant metropolis. And in the science fiction novel, I think it's Neuromancer, it's called The Sprawl in the Future, where it's essentially just one built-up city. So this is looking at how many cases you can have in Williamstown and be in the different color categories. So if you have 1, 2, 3, or 4 cases in Williamstown in a 2-week period, you're gray. You would also be green. So the state metrics are not mutually exclusive. You can be gray and green, but you will be given the lower designation, the lower color designation. If you go up to 5 cases, because of the population in Williamstown, that immediately moves Williamstown to yellow. So it is mathematically impossible for Williamstown to ever transition into yellow. I'm sorry, into green. It goes straight from gray into yellow. So if you have 5, 6, 7, or 8 cases in a 2-week period, you're still yellow. Oh, these numbers don't seem to be the same on both sides. This is a 7 here, and this is an 8 here. I'll take it that these are the numbers that matter. I think these numbers here are just going down.
In the yellow, there are two 6s.
There's 2 6s. Okay, there's decimal points. Oh, okay, so these are the number of cases in a 2-week period. Oh, no, on the left, okay. And then these are the average cases per day, okay. Okay, oops. And then, again, we should just have, next time, just expand it out a little bit so that you can see the decimals. Okay. So when we look at this, we're seeing 8 cases in a 2-week period is coming out to about 7 cases on average per day per 100,000 people. So to put things in perspective, if you have 7 cases in a 2-week period, that's 1 new case every other day. So your daily average would be a half a case, not even a new case a day. But in terms of the state metric, that puts you into yellow. One of the things I really like to look at with statistics like this is how much does 1 data point change you? There is a great formula called the Fonz Formula, the published called the Fonz needle, where if you have a bunch of parallel lines that are equally spaced and you throw rods down on it, you can ask, how often does the rod cross the line? And it turns out it's a rational multiple of pi. And someone claimed to do an experiment to test this and claimed to have thrown a bunch of rods up and marked how many intersections there were and got pi to about 8 decimal places. The result was so good, people were suspicious. And what someone very quickly noticed is, amazingly, the number of rods you threw is exactly the denominator in a great rational approximation for pi. And if you had thrown 1 fewer or 1 more rod, your final result would have been only about 3 digits accurate, even if things worked out as well as possible. This is not a proof that the person chose a good rational approximation for pi and forged the experiment, but it makes it quite likely. And just 1 more data point, either way, would have completely changed the quality of the result. So over here, right now for a small town, 1 more result is going to have a huge impact in terms of the average rate. 1 person in 2 weeks is moving the average rate up by almost a point, by almost 1 case per day. If you have a situation where you expect false positives, and when you're doing as many tests as Williamstown is doing each week, students are now being tested twice, right? We have on the order of 1,600 students on campus. That's on the order of 3,200 student tests. Now, just going from that, now add the faculty and the staff, we're easily at 3,500 tests a week. So an interesting question, and I'll make this a homework problem. If I give you the false positive rate, how many false positives do you expect there to be? Well, if the false positive rate is extremely small, so let's say only 1 in a million, then I don't have to worry about this. I'm not worried at all about false positives. What if the false positive is 1 in 1,000 or 1 in 10,000? Now I start to get worried.
So, I'm in probability right now with President Johnson, and he gave us the same thing with the Northern Institute COVID test.
Yes.
And what we found is that if they give you their false positive rate, they don't actually give it to you. All they say is that the sensitivity, which is like the odds is more than 95%. So the false be anywhere from 5 to 0%.
Okay, so the comment from class was that in probability right now being taught by Professor Johnson, we were told that it's a sensitivity score that's being reported, not a false positive. And that sensitivity score could be somewhere between 0 and 5%.
So a false positive could be anywhere from 0 to 5.
Right. And so if you put in, 1% false positive, which is tremendous, even if you put in a 0.1% false positive with 1,000 tests a week, 3,000 tests a week, you expect false positives. And I'm not convinced that people who test positive are retested. I've heard that some people are not being retested. That needs to be verified. But if you have a false positive that's entering this, it could impact. In a standard math class, let's say you're taking a calculus class and you have homework every day. And every day you have 5 or 6 problems. And the grader screws up one of your problems. Do you get upset if the professor doesn't change the grade book? Oh, okay, so that's not necessarily the right question because that talks about your personality. Will it really impact your grade if one homework problem is marked incorrectly? No, the sheer volume of problems being done is such that it will drown out one homework problem. It's not going to really make a difference one way or the other in what you're doing. You should still get the points that you're owed, but it's extremely unlikely that you'll be precisely on the border and something like that will make a difference. But here, one person can make a huge difference. It can change the average daily rate by more than 1 per 100,000. And that's something we have to be extremely careful about now when we're trying to get a sense of what is going on. A lot of the statistics and metrics we're looking at all comes down to trying to understand, is COVID contained or is it spreading? Imagine you have a family that moves into Williamstown and they self-quarantine because they came from a bad state and they test positive and they haven't seen anybody else in Williamstown, but they move in. Are you concerned? Why not?
Well, they're not spreading it.
They're not spreading it, they're contained. And so even if you have a family of 6 that moves in and they're all positive, if they're not spreading the disease, if they're just staying in their home for the 2 weeks, it doesn't really matter. What we're trying to capture with these metrics is a sense of, is the disease going to be spreading in your community or is the disease going to be under control? Ideally, if you could wave your mathematical wand and have all the powers in the universe, what data would you like to have each week? At a moment's notice, what would you like to have? Okay, so you'd like to know all the social interactions, all the contact networks of everybody. That would be wonderful to have. Think big. Anything you want, it's available. It's like the frictionless plane store from physics and the massless pulleys. Whatever you want, it's available right now. All right, we will know the contact of everybody. We will know how long they've been with anybody. We know everything. What else would you like to know about every person?
If they're sick or not.
If they're sick, if they have COVID, right? As long as we're thinking big, wouldn't it be wonderful if we knew every moment of the day? Hey, oh, look, Joe just got COVID. Wow, how did Joe just get COVID over there? Oh, okay. It would be wonderful if we had data like that. We don't. And the goal of what we're trying to do here is to take into account, well, these are easier variables to look at. And by looking at these, the intent is to try to get a sense of how much is COVID spreading. At the end of the day, it's nice to have simple formulas, yes, no, tell you what to do. This is almost like a triage in a hospital, where when somebody comes in, you start asking a couple of questions, you start getting a couple of key metrics of the patient, and then based on what you see, you decide what to do. And the hope is that these metrics will help us figure out what to do at the town level. My concern is that these metrics are not using enough information. All they're using right now is the very simple number of how many cases in a 2-week period and what's the size of the population. That's it. Only those two pieces of data. It makes for a very nice, simple formula. It's very clear. It's very transparent. But this is something we've seen all the time in the semester, especially in the baseball models. You know, if you include too much stuff, okay, the model can't be done. We've seen this also with rabbits and foxes. But if we include too little, it's unreasonable. And we need to add more information than just this. So in Boston, if you have, 4 cases per week, it's not even noticed in Boston because the population is almost 700,000. You're still green until you have 388 cases in a 2-week period. And that finally averages you to 4 cases per 100,000 for your daily average. And again, if you want to think of Boston as about 700,000 people, and we're looking at averages per 100,000, well, okay, it's roughly a factor of 7, so you roughly divide things by 7. You don't get into the yellow until you have 389 cases. Okay. So the current metric, Williamstown, 1 case over 14 days is 1 case per day per 100,000 people. Okay, so this is because Williamstown has a population of about 7,800, and when you scale that up, when you figure that out, 1 person is equivalent to changing your case daily average by 1. In some sense, as a rough rule of thumb, this means if I want to figure out roughly how many cases per day per 100,000 there are in Williamstown, I just need to know how many cases there are in a 2-week period. If you want to quickly convert from an hourly salary to an annual salary, most jobs work how many hours a week? 40. How many weeks do you typically work in a year? 50 makes it a nice number for me. 50 times 40 is 2,000. So if you want to take an hourly salary and convert it to an annual salary, if you multiply by 2,000, that's a pretty good estimate. And it allows you to do some quick, fast calculations. So we are essentially in the position where 1 case per 14 days is increasing the average by 1. Boston has about 145 cases over 14 days is what's going to come out to about 1 case per 100,000. And the Boston population by the Williamstown population is about a factor of 90. Okay. Anything else that the group wanted to mention for this slide? So this is just to try to set the stage so that we can try to figure out what might be good metrics to include. So testing. Communities should be rewarded for frequency of testing. What is the purpose of testing? To try to find out who has it and to try to contain the spread. The more testing you do, it seems reasonable that you should have a better sense of what's going on. Who is being tested? Are you testing everybody, or are you testing just the people who show symptoms? There was a report today that I saw from the World Health Organization that they are saying, and again, I haven't really read it carefully, that they think 1 in 10 people in the world might have had COVID already. But there are so many asymptomatic cases. Again, I have no idea if this is true. I just quickly saw this as I was preparing for class. But what if the numbers are truly that high? If you only test the people who are showing symptoms, and very few of the people are actually showing symptoms, you are not going to have a good sense. If you wanted to try to have a lower color category, what should you do? Don't test, right? That if you have things that are designed to kick in at different color levels, one way to make sure that doesn't happen is to not test. That is not what we want to do. But you always want to think about and worry about what kind of incentive structure. Are there any fans of women's Olympic badminton? Anybody familiar with the scandal from a few Olympics ago? So one of the Chinese teams realized that if they won their match, they would have to face another Chinese team in the next round. But if they lost, they would still advance. And they were honest about it. They weren't just occasionally missing the shot. They were like deliberately missing and whatnot. So it was quite clear what was going on. At which point other teams said, oh, you want to lose? We'll show you how to lose. And in the end, you had 4 different countries that were deliberately losing matches. And you had fans going, I paid how much for this? And there was a huge controversy as to what to do. It turns out some people had warned the Olympics beforehand that you have created a system where there is an incentive for some teams to lose or not to play well because of how matchings are determined. You always want to think about that when you're doing metrics like this. Again, because of how bad and how much fear there is in COVID, I'm not really worried about people deliberately trying to avoid finding out who has COVID. But you want to think about something like that. It's also much better to give rewards than punishments. And if you're doing extra testing and getting more information, shouldn't a region be rewarded in terms of the color classification for the amount of time and effort and money that they're spending to truly get a sense? And so one factor to try to include, maybe the more frequently you test, maybe the longer it should take you to move up to the next color. So one thing is, if I am tested, am I the only one that we're really getting data about? So who else do we get data about when we test me? Almost surely my immediate family. It's not perfect, but if I'm consistently testing negative, it's more likely that my kids and wife are not infected. What other data might you get? Do you think we're getting any data about the students in my class? Or given that so many people are remote, given that we all are wearing masks, given that we're all well separated, would you say, no, actually, I don't think testing Professor Miller gives any data about the students in his class? So these are things to think about. When we are trying to reward people for more testing, what if we just take, let's use poor Joe again, and we're going to test Joe every 5 minutes. And that's going to be Joe's job. Should we be rewarded for this? No. So what do we really care about? The amount of different or distinct individuals, or maybe even households that are tested. That might be the much better statistic. How many households are tested? So again, there is no one who is thinking of just taking one person and their job is to just constantly shove things up their nose, every 5 minutes. No one is thinking of doing this. But there will be other times in your life when you might be in a situation where people are deliberately manipulating statistics. I have heard that the reason we have a 19-mile-per-hour speed limit on one of the roads in our beautiful college campus is because of US News and World Reports. That something that is under 20 is considered a small class. And so there are a lot of classes at Williams that I believe are capped at 19, so that according to the US News and World metric, they now count as a small class. Whenever you put something out there, you are opening yourself up to people manipulating the statistics, and you always want to think about that. The last is rewards are also better than punishments. I will risk sharing this story, and I know this is being recorded. Years ago, I was teaching multivariable calculus, and after class, I was talking to some of the students, and I was lamenting how, sadly, a lot of your evaluation as a good teacher comes down to how you can manipulate your students. And one of my students said, we're too smart for that, Professor Miller. And I looked at him and said, do you really want it? Yes, okay, fine. So what happened in class today? Well, you were upset because a good number of people were late to class. Okay, so what did I do? You said anybody who was in class on time is excused from one homework problem on the next assignment. And how did that make you feel, Noah? Really good, because I was in class on time. What would have happened if I had said anybody who's late has to do one more problem? Oh, that would be so unfair to them. It's not reasonable. Does anybody know what the next question is that I asked Noah? I did not ask what's the difference between the two, although that's not a bad question.
You have another problem.
I asked Noah, do you know what the next homework assignment is? And his jaw just dropped. He said, I'm just adding one problem to the next homework assignment. But by doing it as it's a reward for people, really think about how you want to sell things and build things. Think about what behaviors you want to encourage. And the goal is to try to understand how this disease is spreading. You want to reward people for doing certain behaviors that you may not be able to legally force them to do. You know, if people choose to do something, that's great. And so maybe communities should be rewarded for the frequency of testing. Another thing that maybe we should include in our statistic is population density. And again, you know, going back to if we had the math wand and we could get any data we wanted, in fact, the first thing that was suggested was to know every interaction of every person at every moment of time. We're not going to know that. The hope is that maybe population density, how many people per square mile, might be a good indicator of how much interaction there is. It's not going to be perfect. You really want to know how much of people are quarantined. You know, for a long time, only one person could go to the supermarket. And so you have fewer people there at a time, and the hope is that it's spread enough so that you're not really interacting. But when you go, in some sense, you're now having the different bubbles merge. You can have towns that are very dense in certain areas and less dense in others. And what really matters is what kind of interactions are happening. If you have, you know, a large section where everybody lives, but they're all staying in their homes, it may not matter if the population density is high. So the question is, how valuable is population density for something like this? It's not terrible, but the question is, how much weight should it be given? The next was a suggestion for contact tracing, general assessment of area and demographics, you know, rural versus urban, mask mandates. And, you know, again, it would be interesting to know how well people are doing about wearing masks, about social distancing, and whatnot. Yes? Oh, yes. Yes, so age would be an absolutely terrific one. Although, do you want age because COVID affects people of different ages different ways, or that people of different ages might interact differently, or both? So there's a difference between trying to figure out how bad would it be if COVID is spreading in the community versus how much do we think it's spreading. And so who do you think has the most interactions? So your college students, you know, you're a great group, and there was tremendous fear about having college students return to Williamstown. And when we were having discussions at the school committee, people are like, you know, it's going to be a disaster when the college students survive, or it might be a disaster when the college students survive. We need to wait and see. You know, for the most part, we've got, was it 5 positive tests, 4 students and the faculty staff, and 17,000 over a month and a half. This is almost in the level of noise. Older people may not mingle as much, you know, especially if they're in a long-term care facility. And so, in terms of the demographics, you really want to get a sense of the people who are infected. Can you say something to rate how bad of an infection that is? Who might be one of the worst people to be infected? Okay, so it comes down to what do I mean by worst? I mean worst in terms of spreading the disease, not in terms of it's bad for them.
Probably like a doctor or someone that.
What was that from Zoom?
Instead of doctor.
A doctor. You know, a doctor would be a terrible person to be infected.
Or a nursing home staff member.
Nursing home staff member would be a terrible person to be infected. You know, a teacher, probably a terrible person to be infected. What about a mailman? I don't know, because, you know, they're not going to be seeing maybe as many people, but they're touching things. So, you know, the question is always, how detailed do you want things to be? You don't want to have an equation that's so long and so complicated that you don't have the data to feed into it. I think I shared with you my father when he was getting his MBA, his teacher gave them an equation with 46 parameters to describe what the company should do. He goes, I don't even know the values of these for my own company, let alone our competition. It's a useless formula. So when we're trying to put something like this in, to some extent, to keep it simple, stupid model is not a bad thing to just constantly be focusing on. That, yeah, yes, it would be wonderful to have all this data, but it's going to be so hard to get the data. The other thing is there's also privacy issues. I have done a lot of work with students over the years working with medical providers in Berkshire County. And one of the problems is you have to be extremely careful because when it's small communities, it's often possible to figure out who somebody is by knowing a little bit. When I was a graduate student at Princeton University, I was a house advisor. It was kind of the graduate equivalent to an RA. There were 2 house advisors, one myself and one of my friends. One male, one female. And when you looked at the questions Princeton asked in one of the surveys, there was enough stuff because at one point it asked you, are you a RA or house advisor? Are you male or female? Are you a graduate student, undergraduate? You know, there was enough information there that I was uniquely specified. And again, it was something that didn't really matter. I didn't really care that people could determine who I was. But with a lot of this, there was the real danger of someone's identity becoming known, and you have to be careful. So there is certain data that you will not be able to get. When we have done work with local healthcare providers, what we frequently do is we work with Business Incubator Lever in North Adams. We have a laptop that is kept there. Its Wi-Fi is destroyed. Its USB is destroyed. There is no way to get data off it once we put the data on it, unless we go through an incredibly elaborate procedure, just to make sure things are kept very secure. So when you're trying to think about what you want to include here, these are wonderful things to include, but to do too much of how much interaction is going to be a real challenge. This is why larger things such as population density or rural versus urban, broad categories like that might be the way to go rather than really nitpicking because we just can't get the data. Right. And then is it worth clicking on this? Is this different than things we have shown? Okay. So right now it says multiply the current metric by the square root of 2 divided by x. So x is the percent of the population being tested bi-weekly. So in Williamstown, it would be about 30%. And is this because you assume that most towns are testing at around 2% a week?
Yeah.
Do you have data for that, or is this just, let's just put 2 in for now and we can adjust that accordingly. So 2 is like a placeholder. So whenever you have statistics like this, you want to get some sense of, are they reasonable? So one possibility is you might put in, if you test less than 2%, you're going to be penalized.
That's one of the questions that was thinking of bringing up is, how do we balance that with 2%?
Well, so one thing you could do is you could put in a max of the square root of 2 over x and 1. So that means even if you test fewer, you won't be penalized. But if you test more than 2%, there's a gain.
Yeah.
So by putting in a max function, it's still a very simple formula to do, and it gives you a lot more freedom now. And so in Williamstown, 2 divided by 30, so if we're really testing that high, we would now be about 17 cases in a 14-day period would be required to push us into yellow, and about 34 for red. And that's very different than 5 cases pushing us into yellow. Now it's important to remember the goal of this is not to justify a predetermined belief of what we should be based on the number of cases. It's to try to come up with what is a really good indicator of the true state of COVID in parts of the county or parts of the state. If you were to test everybody, would you need to try to figure out how to extrapolate? No. I was at a Phi Beta Kappa Senate, Phi Beta Kappa national meeting years ago, which was a complete disaster in voting. There were 9 Senate seats open. Each seat has to have at least 2 people running. So we had 18 candidates, and you have to get a majority of the votes to become elected as a senator. And this is where I sadly made my national prominence, and I am now a senator of Phi Beta Kappa. We quickly elected a couple of people. And after a couple of rounds of voting, we now had 10 people left and 1 Senate seat to fill. And no one was close to 50%. And we kept voting and voting and nobody was. So finally somebody said, I move that we change our voting procedure and whoever has the fewest votes is eliminated from the next round of voting. Well, this is changing the law, the rules of an election in the middle of an election, which requires a supermajority, and that failed. And then there was another rule change which failed. And then somebody said, well, you know, we really shouldn't be doing this and removing whoever has the fewest votes because this is just statistics, it's just a sample. And then a statistician raised his hand and said, actually, it's not a sample, the entire population is voting, we know how people feel. The solution which I finally came up with is that Steve Miller, Williams College math professor, if people just want to stop voting for whoever had the fewest votes, thank you. And it was much better not to change the rules. Just tell people, just stop voting. If enough of us just stop voting, we move on. But there's a huge confusion sometimes between a sample and an actual population value. Typically, you can't get the population value. If we could test everybody, we could. And so the idea is, if towns are doing a lot of testing, they should be rewarded because you have a much better sense of what the metric is, of what is being shown. And again, you have to figure out what is going to make a convincing argument because it's a reasonable argument. And if we could test everybody, what if we tested everybody in Williamstown and only 5 people tested positive? Is that the same as testing only the symptomatic people? No, because when you test a small segment and 5 people come out positive, you extrapolate and you say, well, 5 people tested positive, we think it's much worse. So to me, something like this is absolutely reasonable and defensible. Square root of 2 over x, no. Up for grabs as to what the best weight function is. But the fact that there should be some kind of weight, some kind of reward for increased testing, to me is clear. I'll just leave it as the word clear because this is being recorded. All right, so here's a plot of how things might look with different factors. And so the blue is 2 divided by x. Is this 2 over x to the 0.5? Is that supposed to be the square root of x? That's the square root of x. And then this was another thing I've suggested, is do ratios of logarithms. And that kind of smooths things out a little bit. This is a little bit hard to see in terms of just how far it goes. I put the plot I did using very similar. You want to make sure you can go all the way up to the top and see. So this is 5 cases in 14 days. And so this is just, plotting 5/14. This is the current color as to what the state would give you as your average daily case rate per 100,000 if 5 people tested positive in 14 days, and the x-axis is your population. And so when you go all the way up to 100,000 people, 5 in 14 days goes down, not surprisingly, to 5/14. But when you have a very small town, like Williamstown, here it is at around 5, putting us into yellow. If we just do a log ratio, so we multiply by the log of our population divided by the log of 100,000, that's going to be a very small rescale, but it is enough to lower Williamstown by a bit. And to try to take into account maybe a little bit of the fact that it's a small population. I think the number of tests is a much better factor to put in than population size. Yes?
One of the biggest problems I saw with doing the previous square root of 2 over x is that we have, isn't measured the amount of distinct people that get tested in any area.
I think the amount of distinct people in an area can be obtained, yes. I'm not worried about that. The number of people who get a number of double tests, triple tests, quadruple tests in a week or 2 weeks, I think we have information to get something like that. There are certain people who have to be tested weekly, and so if we know that, we can incorporate that. And the hope is, of course, that something like that is a lower order effect. So again, this shows you how going to logs, going to square roots, greatly changes. But you have to then justify, is it reasonable to adjust a town by this? that maybe smaller towns are not going to have the same kind of interactions as larger cities. That's to be harder to justify. The second option was looking at the average new cases per day, C as cases in 2 weeks, R as the percent of population tested, and X is a scale factor representing population density. So, you have 2 over R to the 1.33.
Yeah, I was just because if we did it again with the 1/2, then the numbers would be like way too high. It was just like give it less of a reward for testing.
Okay.
You're gonna factor in like 2 different things.
Okay. And so, again, the actual formula right now is completely up for grabs. But the idea is to try to have 2 factors, 1 factor for testing and 1 factor for the population density. And the population density should in some sense be normalized so that a town of maybe 100,000 in a certain geographic size has a factor X of 1. So some kind of factor like that as a way to take into account interactions. Instead of that, you might want to have some kind of designation. And you could have these highly interactive towns all the way down to, I have neighbors. All right, and so here is another one, same one. Okay, and this is just for Boston. Okay. And then here's the idea I came up with as I was walking to class today. So I've been working on the school committee for about 3 lifetimes now. And one of the things you learn is that town managers hate uncertainty. For good reason. They have to make sure that the town has a budget to do the things that need to be done. You don't want to drop on somebody, oh, by the way, yeah, I know we're voting on the budget tomorrow night. There's a 15% increase across the board. Good luck budgeting for that. So a lot of times, towns use rolling averages, 5-year averages, if possible. We do that in the regional agreement between Williamstown and Lanesboro in terms of allocating the cost of the schools to the 2 towns. And one of the key factors is how many students does each town send to the middle high school? And we look at a 5-year rolling average. So if all of a sudden you have a big class coming in or a big class leaving, no town is going to be hit with a huge shock to their budgets. This gives you time to prepare and think. Okay, we are graduating a very small class, and we have a very large class coming up in kindergarten. We can see in a few years, this is going to affect the ratio at the middle high school. We can start preparing for that. For other things, we unfortunately use 2-year averages, which it's better than a 1-year, but it does give you a little bit more sensitivity to shocks. What if we had some kind of weighting by averaging over towns that border you? And again, I don't know if geographic bordering is the best. We talked about spatial analysis earlier, where I think Williamstown might interact more with Albany, at least in the pre-COVID times because of the airport, than in any of the towns like Colony, for the most part, between Williamstown and Albany. Modulo maybe having some kid games between the two. You could look at the different youth sports leagues that are going on. But maybe because the numbers are so small, because the town populations are so small, we're talking about case loads per 100,000. Berkshire County is 120,000 roughly. So we're basically talking about how many cases are there in Berkshire County? Williamstown, any town is so small that small fluctuations are going to have a huge impact. What if we take a beautiful town like Cheshire, which is surrounded nicely by these towns here, and maybe we average and look at the value for Cheshire is not going to just be Cheshire, but maybe Cheshire is going to be most of the value, maybe 60%, 70%, and then weighted a little bit by the towns that are around it. And again, what that rating should be, I don't know. How far you should go, I don't know. And again, it would be wonderful if towns were either circles or squares or hexagons. It would make things a lot easier in terms of taking these into account. When you look at a town like Darlington, which is very vertical, or Hancock, it's stretching over a large area. It might matter greatly where the people are. But again, just as something else to think about in terms of trying to come up with a more reasonable metric as to what's going on.
This only applies to towns under a certain population.
Well, so that's the whole thing, is that when you're looking at some of these things, I remember at one point the school committee was temporarily concerned because New Ashford had a 10% positive test rate. And then we found out that 10 people were tested and one was positive. And so yes, it's a 10% test rate, but 10% of 10 people, well, how worried should I be? I'm concerned that somebody tested positive, but that's very different than a 10% test rate of 100,000 people. And so with the small numbers and trying to get a sense of just how much is COVID spreading is the right way to color a town, to just look at what's going on in the town, because fluctuations, small fluctuations, have a tremendous impact. Or is the solution to maybe do some kind of spatial analysis and do some kind of averaging and say that, look, Berkshire County, you could look at the entire county is yellow. So while there may be a few more cases in Williamstown, is it really spreading or is it contained? Same thing for a lot of these other small towns. Because it is such a small population, you can have a couple of years that just become yellow just because of just how random points are distributed. And of course, these are not entirely random, because it wouldn't be surprising if someone is infected, if they infect people who are close by, but just trying to come up with metrics. So there is a chance that Williamstown, we have just opened our schools today. There's a chance we will have to close schools to in-person instruction on Thursday when the new numbers come out, because we have now been yellow for 2 consecutive weeks. So I will be talking with the superintendent later today. Hopefully he will be talking with the Commissioner of Education. So anybody who is listening today, please email in the very near future any suggestions, thoughts, comments, things that we should do. And again, I think it's okay if we go to the state and say, we don't have the full solution, but we have some suggestions and we have some things that would be worth considering. Have you thought of the following? Have you considered the following? And they may have said yes. But there are other things that they may say, oh, we had not thought of that. I was one of the first people to propose, and it's not being used, that we should have people sitting in hexagons in classrooms. It will allow you to have the 6-foot separation and put in a few more kids. And again, it's just sometimes it's just thinking out of the box, and you're so used to doing things one way. Right now, this is an easy statistic to look at. Number of cases on average per day per 100,000. But it's not capturing what we want it to. And so the suggestions that we're getting today is how to push it forward better. Right, so I want to thank the metrics team again for all the work that they did on this. Slide up again. And then please again send me comments as soon as you can over today and tomorrow.